Welcome to the math record. For the last week of April for our whatever class, we're going to be integrating sine of x raised to an I power. So imagine you're given a question like let's say you want to integrate sine of like 7x, sine of x raised to a 7th power, or you want to find the integral of like sine of like 5x, sine of x raised to the 5th power, or like sine of like 9, sine of x raised to the 9th power. Sorry if I keep saying that. If I say sine of something, it's gonna just be that power. So like, how do we get these integrals, right? Powered of sine. Well, first we can make a general case. So we have to take the integral of sine. So we want an odd power. We could just say it's 2n plus 1, right? So even plus a odd is gonna always be an odd. And then instead of saying just x, maybe let's call it ax, right? A is a constant. I just like to use a. So if you're using k or c, that works too, which is usually what calculus does. But I like to use a. Okay, so we could split this integral up and say it's sine of 2n of ax times sine of ax dx. So why am I able to do that? Well, that's just basic exponential rules, right? So since these two are the same, basically we could just multiply it. So this is an extra sign, so you gotta add a 1 here, basically. So that's why we split it. So instead of adding a 1, we subtract a 1 and then make it right here. And then we use another exponential rules with powers, and we write this as saying sine squared of ax to the power of n times sine of ax times dx, right? Because you just distribute out the n and then raise that to that power. This is just basic exponential rules. Okay, so let's move this up so that we get more room later on. So why do I do this? Well, basically, we have a sine squared of ax. So with the special, because this is like a special property with odd ones, because when this is like when it's odd, it kind of makes even function. And then with this even one, we could make we could substitute it with a Pythagorean trigonometric identity, and we could say this is 1 minus cosine squared of ax, right? That will be equal to sine x, and that's raised to the power n times sine of ax. So the reason we did this is because when you take the integral of cosine, you get sine, and when you take the integral of sine, you get cosine, right? So they're kind of alternating. So then when we want to take the integral of these higher level like sine trig functions, what we have to do is that we kind of have to do it like a u sub. So u is equal to cosine of ax, right? So what's the derivative of this? Du is equal to negative a sine of ax dx, right? And then you can rewrite this as saying it's like negative 1 over a du is equal to sine of ax dx, right? And you can substitute this into here. And then you could have integral, and you substitute this one into here, right? So the integral of 1 minus u squared, right, because it's cosine squared of ax to the power of n, right, times, um, we substitute sine of ax dx with 1, negative 1 over a du. So now everything's in terms of u. Okay, and then since negative 1 over a is just a constant, we can move that out. So negative 1 over a integral of 1 minus u squared, the power of n du. And that is the general formula that we're going to be using the entire time. Okay, so remember our n, right? So the power is equal to 2n plus 1, right? Because remember our power was 2n plus 1 in the beginning. So that's what our power was. And remember that our u is equal to cosine of ax. So we will just substitute this later on back in because this is in terms of u. We want it in terms of x. So let's do some integration. So let's start off something simple. Let's integrate sine of, let's say, 5x, right? So our power is 1, right? This is just power 1. So if our power is 1 using this formula, that means our n has to be 0. Okay, so we have 1 over a integral If n is 0, then this is just going to be 1. So the integral of 1 is just going to be u, right? Because this is in respect to u right now. So we have negative 1 over a u. So what is u? We substitute this back in here, right? So we have negative 1 over a cosine of ax. That looks kind of bad. Ax, right? And what is our a? Well, it's right here, 5. So we just plug in, for every single a, we plug in 5. So it's negative 1 over 5 cosine of 5x. And that is our integral. And if you want to make it like proper, just add a c, right? It doesn't really matter. Well, it does matter, but like usually I just don't like I don't really care about it too much because this is the correct integral. Okay. Now let's now since that was like the easier one, you could just like check it again to make it sure, make it right. So integral of cosine sine, which is negative, and then it cancel out this negative, and this 5 times this 5 is 1, right? So then it's gonna integrate right. So let's try something like a little bit harder. Let's say we want to find the sine of 7 of, I don't know, 2x. Let's get integral of this. So following the formula, 1 over a integral. So what is our power? Well, this is 7. 7 minus 1, that is 6. 6 divided by 2 is 3, so n is equal to 3. Okay, so 1 minus u squared to the power of 3 du. Okay, so we have negative 1 over a, and then we could integrate this part. So integral, but let's expand this out first. So that will become 1 minus a 3u squared um, plus a 3 u to the power of 4 plus a u to the power of 6. I mean, negative u to the power 6. Right? It's just like a polynomial. You could just like, if you want, I could show the work of how this works. So 1 minus u squared, and then 1 minus u squared, right? It's just raised to the power 3. So then doing just these two by itself, that's just 1 minus 2u squared plus u to the fourth, and then 1 minus u squared, right? So then when we distribute out, we have a 1 minus u squared, and then minus 2u squared plus 2u to the fourth plus u to the fourth minus u to the sixth, right? So 1 and then u squared, negative 2u squared, that's negative 3 squared, u squared, and then 2u to a fourth plus u to a fourth, 3u to a fourth, and then negative u squared, u to 6, right? So you could just follow the basic binomial theorem and how it kind of like expands out. Okay, and then du. And then we just integrate this. So the integral of this is put negative 1 over a integral. Oops, sorry. So the integral of this is u minus, so this is already going to be a 3, so just u to the power of 3. And then plus, this is going to be a 5, so this is 3 over 5 u, sorry, 3 over 5 u to the power of 5. And then this is going to be a 7, so this is 1 over 7 u to the power of 7. Right? So 1, 3u squared, and then plus 3u fourth, and then minus u 6. So, and then you can add a c if you want, it doesn't really matter. And then and then all we have to do now is that we have to substitute the u with our cosine of ax. So remember, our a is what's inside, so that's our 2, so that's negative 1/2. Our cosine of 2x, right? Our a cosine of ax, where a is 2, minus cosine cubed of 2x plus 3/5 of cosine to the power fifth 2x minus 1/7 cosine 7th 2x, right? And then you can add a c, right? And that's basically how you could use this general formula to find the integration of sine of x raised to a power. I hope the video was entertaining and helps with your integration in calculus class. Well, thanks for watching, and I'll see you at the next math record.